Let me say that again, and let me draw this section of it cleaner, because I kind of scratched through that drawing. When we have a one-to-many relationship, as we have between class and assignment, somehow that assignment has to say which one class it belongs to, right? Because an assignment only belongs to one class. We need to implement that relationship. How do we implement it? Well, how do you point to one row in this table? The way you identify a row uniquely is via the primary key. Therefore, I have a foreign key in this table that points to the primary key in this table. So, maybe class ID of 1 is biology. Class ID of 2 is chemistry. Class ID of 3 is physics. All right? That's the class table. I omitted the room and the time. In the assignment table, maybe assignment 1 is a lab worth 5 points. And what class does it belong to? Let's say it belongs to chemistry. Therefore, it would have a class ID of 2. So it would point to, yeah, this assignment, the value of the class ID in it points to chemistry. So it has a value of 2. Maybe the second lab, or the second assignment in here, is a quiz for physics, and it's worth 10 points. Well, then it would have a class ID of 3. So, whenever you have a one-to-many relationship, the many side points to the one side. It does so via what's called a foreign key, and you end up with that. We now have the two intersecting tables. The class student table. All right. And what I call the grade table, which alternately you could call the student assignment table. The class student table, again, as with any many-to-many relationship, it has the keys of both the tables that it's joining together. So the primary key of this table would be a combination of class ID and student ID. And those would be foreign keys to their respective tables. Let me draw that part of it. Again, if the class table has class 1, biology, class 2, chemistry, class 3, physics, and the student table has student 1 is Mike, student 2 is Joe, student 3 is Fred, student 4 is Leslie. All right. If Mike is in physics, then the student class table will contain that Mike is in physics. It matches up. That's the purpose of this intersecting table. List of all the classes, list of all the students, list of all the combinations that are valid. If Mike also took chemistry at the same time, I would have Mike is also in chemistry. How can I have duplicate student IDs in this table? Because the student ID by itself is not the primary key. The primary key consists of both parts, the student ID and the class ID, which means the combination of those two things have to be unique. In other words, if I'm in the physics class, I'm only in the physics class once. I can't be recorded as being twice in the physics class. which makes sense, right? You know, you take a class, it's not that much fun. You're not going to take it 2 times, you know, at the same time. All right. Questions about this? This is how you implement many-to-many relationships. Intersecting entity, where the key of the intersecting entity is a combination of the 2 keys. All right, a multi-part key. So we have a formula for one-to-many. We have a formula for many-to-many. Those are the most common relationships. Later on, we'll talk about one-to-many, or I'm sorry, one-to-one, but those are pretty rare, so we're not really worried about them. Now, my grade student table what's the primary key? An intersecting entity. It will be the primary key of the 2 respective tables. But it will also contain the points that the student earned. Right? The fact that in the assignment table we may store that the quiz was worth 10 points. In the grade table or the student assignment table would put in that Mike on this assignment got 4 out of 5, for example. All right? Or 8 out of 10 or whatever. Questions about this? All right? We will, again, we will practice this more and more. I will do examples. You will work on examples, and we'll evaluate this. It's important, again, cannot emphasize enough the importance of this. That's why we go over so many examples. You got to get this right to get the benefits out of the databases. All right? And I'm not sure what week it starts. At a certain week, we start talking about normalization rules. All normalization rules are a way for us to look at our design and see if we've kind of a checklist to say, hey, did we follow these rules? If we did, that gives us a reasonable assurance that we probably did a good job designing the database. And we'll talk about those either this coming week, next week, or the week after. I can't really recall. All right? Questions over any of this? All right. Thanks a lot. We will see you in lab.